Hello guys, today we are going to see a problem where we will be given an array. We need to find an element in the array such that the elements towards its left are smaller and the elements towards its right are greater. So given this problem, people used to think that it resembles like the partition logic in Quicksort. So the partition logic in Quicksort picks the element and inserts into the right position in the array such that all the elements towards its left are smaller, right are greater. But that alters the position of the element in the array. This question is little different that we need to find an element in the array such that the elements towards its left are smaller and right are greater. So I think there is a subtle difference, and this is the mistake that people usually do when they see this problem. So given that, let's go to the problem. I usually don't write the main methods as driver function, but in this case I have written because this requires a little explanation. Let me run this code and then explain. So we are given an array where the elements are 4, 3, 2, 7, 8, 9. So the first element in the array where the elements towards its left are smaller and right are greater is 7. So if you take two elements towards its left are not smaller but right are greater. When it takes anything after 7 elements, after 7 is greater than uh, the elements towards the left are smaller and right are greater, but we need to find this index. And it also means that the elements towards its left need not be in sorted order, so that also is the case. So the algorithm goes like this. So for this problem we have to think a little differently, where we need to find the left maximum and the right minimum and find the intersection point in such a way that the element the left max is less than the array element and the right max is greater than the array element, and that is the element where we will say that from that point all the elements towards its right are greater and all the elements towards its left are smaller. So let's see how we find the left max. So the left max is initialized to integer dot mean value. It can be the zeroth element in the array as well. Yeah, but I've used integer dot mean value. So so the left size of the left max array is the size of the array itself. So for integer I equal to 1 and I less than the input array dot length, the left max of I is calculated as the max of the previous element in the array and the max of and the element in the left max array. So if you see the array which is 4, 3, 2, 7, 8, 9. So if we are calculating the left max of the second position in the array, which is math dot max of 4 and minus integer dot mean value, which is 4. Second element is if we have to find this position, third position, go to the second position, math dot max of 3 and 4, which is 4. Then the third is math dot max of 2 and 4, which is 4. And the fifth position is math dot max of 7 and 4, which is 7. And the sixth position is math dot max of 8 and 7, which is 8. So this is how left maximum is filled. Let's go to how do we find the right element. It is just the reverse way. It's assign the right minimum of the last element in the array to the integer maximum value, iterate through the array, and right min is instead of max you use math dot min of the array plus 1. For example, the right min of this is math dot min of 9 and 2147, that int max are values, which is 9. So the right min of this position is 9 and 8, so which is 8. The right min of this is 7 and 8, which is 7. So the right min of this is 2 and 7, which is 2. The right min of this element is 3 and 2, which is 2. So now we have calculated the left to max array and the right min array. So how do we intersect it and find the apt position in the array? So when we consider an array towards its left or smaller and right or greater, so those elements will not be in the first position or the last position of the array. So that is why we initialize this, even if we initialize it to 0 or whatever, probably interminable value or the 0th position in the array doesn't make any difference. So it's better to use int min because that will ensure that there will not be any minimum element which is less than that position in the array. So you are getting the logic, I think. So I will repeat this thing. So if we have to find a element in the array where all the elements towards its left are smaller, it cannot be the first position, the 0th element in the array. And if we need to find an element towards its right or greater than it, it cannot be the last position in the array. So we have to find the element between 1 and n minus 1. So that is why we are iterating to the array from 1 to n minus 1. Probably this is the one thing which we need to understand before writing the third step, because arriving at right max, right min and left max are little easier. This has to be said. So I am iterating from the first element to the length minus 1. So left max of I is if left max of I is less than ARR of I, which is 2 less than or this is the limit, right? So left max 4 is less than or equal to 3, no. And right min greater than ARR of I. Right min is 2 greater than 3, no. So we are moving forward. So the next is 4 less than or equal to 2, no. Or 2 less than or equal to 4, no. And 7 greater than or equal to 7. So hold on for a second. So I got confused here. So for the benefit of understanding, I just paused the video and put a system.out.println so that we see a proper line break. So what I do is, for I equal to 1, I less than array dot length minus 1, I plus plus. So we go to the first element in the array, which is 3, and the first element in the left to max, which is 4, and the first element in the right min, which is 2. So the condition goes like this: if left max of I, which is 4, less than or equal to ARR of I, which is 3, no, the condition is false. Let's move on. But even then we will check for the understanding purpose. If right min of I greater than array of I, if right min of I, which is 2, greater than ARR of I, no, false, we go to the next element in the step. So where we what we do is the third element, if left max of I, which is 4, greater than or left max of I less than or equal to AR of I, no, 4 is not less than 2, and right min of I greater than array of I. Right min of I is 7. We are considering 7 greater than or equal to AR of I, which is true, but anyhow the first condition is false, it goes back. And the third, so we have considered this 4. If left max of I greater than or equal, if left max of I less than or equal to AR of I, which is true, 7 is less than or equal to 7, which is 1, 2, 3, 4th element here, 1, 2, 3, 4, 8 element, 8, right? So right min of I greater than or equal to AR of I, which is 8, greater than or equal to 7. So we have found the right position in the array, which is the answer. So I return that AR of I position, AR of I, which is the fourth element in the array, which is 7, and that's what is the answer. So as we usually do, I have written a test case which captures this array. Find this position, run this test. So the answer is 14. If you see this, as I clearly told previously as well, the 7 cannot be the answer because that's the first element, and 18 cannot be the answer. So for after, this is a sorted array where 14, any element before that is shorter, less than, and the element after 14 is greater than. So let's take a different input and run this test case. Oh, there is okay, so I have to change it. 7. That's what happens when you do a live coding without understanding it. 7. So if we see it, any element after 7, before 7 is less than, after is greater than. Let's go to the third test case. So we need to find it is should be 6. 6, anything before 6 is smaller, anything after 6 is greater. So it has to be 6 here. I will change the test case to 6, and let's see if our program runs. Yes, sir. So the same problem can be solved without using the right min extra array. So I would leave that as your homework, or your practice, for your practice. And if you could solve it without using extra O of n, or we are using 2n extra space, if you can use it with O of n extra space, that would be good, and post that in the comment of the video. This is one of the longest videos that I have recorded. Thanks for your time. Let's meet with a different problem in a different day. Thank you.